Hi, welcome back to yet another PlayBASIC live video. Here we're discussing or taking you through this idea of externalizing command sets. Let's take a look at, we've got a mock-up here. We'll go back here to it's a bit of theory here. I was jotting down about how this is going to work. One of the problems with externalizing command sets from the main runtime is that if all the command sets are written as a big blob of code and they'll interact with each other at some level, it's convenient to write things like that. If you want to have a situation where you can include some parts and not others, or you can possibly switch out some functionality for alternate functionality, which is what I would hope we get to, we just can't follow that model anymore. So what we need is, here I'm talking about the objective here is to have the VM allow external command sets to request and share commands between them. So when I'm talking about commands, I'm talking about it able to locate where that piece of code that does that command is in memory, whether it's inside the runtime, whether it's in an external command external command set like a DLL in Windows vernacular, or a separate DLL. So we might have DLLs for each of the command sets. We might have one that deals with images, one that deals with sprites, one that deals with maps, etc. If you're not using the maps, you just can exclude the maps command set. Save yourself a bit of memory and avoid that sort of potential collisions. Or maybe you want to swap out the map command sets for an alternate version. That's what we can do here. The way this is done traditionally is that you've got these lists of pointers and where the commands are in memory. The VM knows where all the functions are. It goes, hey, I know where the create image function is. I'll just call this function for you. When you type load image such and such, it sets up a call, grabs the variables that you're passing it, and launches control across to that function. It does its job, in this case loads the image, then returns back to the runtime. That's at runtime. Now what we want to do is we want to have a process before this even starts, so it runs through and can locate where things are in memory. To do this, I've got a few different ideas in my mind, but this mock-up here in PB is kind of to help me and help anyone who wants to wrap their heads around this process visualize what's going on. So in this next paragraph here, I'm talking about if command sets are able to locate commands within other optional sets. So the example I gave the other day was about if we were talking about the banks commands and I wanted to add a command that can load some data from someplace and create a bank out of it, then if I'm working within the banks command set, I need to have things that obviously they open a file, they read some data off a disk or a device of some type, and let me close the file. Now, every time I want to load data, I could just write those functions and drag them into the command set, but it's extra bloat. For the things like the file system, it's probably not too bad. There's lots of OS support functions we can call to do those things. But what we could do, we could have each command set be able to publish an internal list of what functions it's willing to make available to other command sets. So for core things like file reading and that kind of stuff, we could use the internal optimized command for like read memory, for example. So we can have a function, we could call the open file function, call the read memory function, close the file down, just like you would in sort of PB code. So we can reuse code that I know is pretty optimal, and if we change the behavior of that code in the future, if we find a better, a more optimized version of that function, then all the command sets that are utilizing that function as well see that benefit. They don't if you pull all the code into each separate command set. You end up with a lot of bloat, and this is going to introduce some bloat as well, by the way. We just can't avoid it. let's go through the logic. So here I'm nutting out the basic idea. This occurs before your program starts executing. So this is when the application is starting. It's going to load in each command set and then perform these requests, this mechanism here. So stage one is we load the command set either from externally off disk or from in memory. So what we'll do most likely is load these things from memory. Sometimes it can be useful storing things on disk because you might want to allow people to change elements of the product later, which is why I kind of 50-50 about those things actually. Once we've loaded let's say you've got 4 or 5 command sets that you've included. You've got your image command set, you've got your basic rendering stuff, the banks library, since we've been doing that in recent examples, but sprites or whatever, or maps or whatever command sets you wanted to have. They'd each be loaded in, they'd be opened effectively. Once they're opened, we go back through and we check them, we ask them, do you have a particular function that can export any public functions back to the VM in this case, or the executable? They either will or they won't. If they don't have any exported functions, no skin off, nothing occurs really. And a function that exports the commands within that command set that it's willing to make public, and another function that we call that has functions that it does not know where they are, but they are external. So the process is basically if we go back to actually look at the process here. This is an emulation of how this will work. This is written in PB code, of course. So we've got a thing to add the command set. We're just dumping it into an array. We've got a function to find the command set by name. We've got a function that's called when we add public functions. So we're adding the function to a list of functions that are under this particular command set. If I run it over here, we just have this kind of weird output. There's nothing visually to be seen. We have a lot of debug information happening. So the demo is set up to have 2 command sets that I've told it exist, file and bank. Once it starts to open them, it goes, okay, here it's found a number of public functions is 3. It's found a function in banks called create bank, delete bank, resize bank. I didn't find any for file because I didn't bother to make any. Then we have a secondary part here where it's going the process is basically this. We run through and we ask each command set, what are your public functions? We put them all in a big central list. And we go back through and we ask them, hey, what functions do you need that aren't stored in you, they're stored somewhere else, in some other library, and they're requested by name and by command set and by name. So it's just a bit of text pretty much. I'll show you that in a second. Right now, in fact. Look at the banks command set. We've got this initialization function. So when in a PB project, it makes little sense to do this, but when the VM is starting, we're calling this bank command here in it, not directly. There's no direct call of this anywhere in the program. I'll just show you that in case you're not really sure what's going on. We do a search, we do a find. All we find is the bank. We're going to find in project, thank you. So we find one location, and that's the actual function itself, because it never calls this function directly. It just uses the call function, and it uses the the prefix of the command set name and this secondary thing to make up the name of the function, which is the init function. So each command set will have their own initialization function, which gives us information about how many functions we're going to export, how many functions that it uses that are currently unknown to it. So they're used inside the library, but they're declared somewhere else. Look at the process itself, which is down here. It's a bit of a slab of code to do something so trivial. Here we are here. This is the process as like some of this we're emulating what's happening, but the principle is what we're trying to get to. My dog's having a dream. So VM startup will do all the heavy lifting and get the runtime up to speed. We've got a function here that declares a couple of functions that are part of the VM. Have a look at those now, I guess. We create a core command set called core, and we add functions called VM set error, VM get error, which are necessary if we ever want to report errors back to the runtime. That's how we do it. Otherwise, there's no way of making the runtime stop if something goes wrong. So we build this, we add these, we add a command set and we add those functions. And the functions exist in the bottom here somewhere. They're just empty functions with some print statements in them. And they do get called at the end of all this convoluted crap. Right. So we pass at startup, I'm telling you here, yeah, I want you to open the file command set and I want you to open the bank command set. It's defining its internal functions because it needs those in case libraries or command sets need to call back into these its own provided functions. We get the name of the current command set. Where are we? About here. Get the name of the current command set. We add it to here. We probably should check if it already exists. Actually, it's probably one misnomer there. But unless that does it already, because it could, in theory, you might have the same command set defined in different DLLs for some reason. And this would create two instances rather than one. But yeah, it's a demo. We make some function names. So we're using if we're processing the file section, this makes a name called file.init and then file.bank, and then the second loop through it creates a name called bank.init. We check if the function exists, which is pretty much an emulation of what's going to happen in the actual thing. It'll do, in Windows there's a function you can call to request, does a certain function exist in a function, within a DLL. If it does, great, we can call it. If it doesn't, we just skip it. So here we're asking it, does the initialization function exist? If it doesn't, then this DLL doesn't need to be set up at all. It could be a third-party DLL that has no understanding of PB at all. So in those cases there, we couldn't have exported functions from it. At least I can't think of a way of doing that today anyway. You might be able to wrap it, I guess, in some way. Once we know the function exists, we call it, and this fills out a bunch of information. We're talking about the banks library. This here will call this function here, this bank init. We're passing it a pointer, and it fills out the fields in the pointer. In this case, just two simple things. We've got the number of public functions we want to make available to other command sets, the number of functions that I need to find that are located in other command sets as well. How's that for convoluted? So here we're going, how many functions do we have? And we're storing this data here for later use about the number of command sets that are public and the number that are external. If we have a number that are public, we go, okay, let's loop through and we'll call our get public function, which is the one down below here. Now here I've sort of hodgepodge this together. I'm using a select case statement. We step through, on the first time we step through, we get this string back. We check that this is actually a function that exists within it. In a C version, this doesn't need to be done. But in here, it's just like a nice, I just wanted to make sure they did exist before I exported something. We dump this into some memory, we poke the string into some memory, and we get the point of that memory and we pass it back, and we return for the function. Oops. We return for the function. So back in this loop here, we're calling our get public function with this index, and each time we go through, we're grabbing different functions from it. If I run it again, we'll see it's part of the code in the console. This is the section here. So it's finding these three function names and adds them to our internal list of these public functions. Once we're done with this thing, this pass, which is all that really does, we loop through all the command sets and do the same thing. We go, do you have an init function? If you do have an init function, give me a list of your functions you want to export. Are you happy to export? And I'll store them in a bit of a central database. We just keep going through. But at the very end, we go, okay. Then we loop through the command sets again, but this time we are checking to see, do you have functions that are undefined, which is what these external command set, this external function list is all about. The same principle. We have a function called getExtern, back in banks here, for example. Again, pretty convoluted. GetExtern, we're giving it an index, which could, in C, it'll just be an array. It has to be set up, I guess, at runtime. It's pretty awkward. It's ugly in C in some regards. We pass in, we pass in a pointer to a structure that has information, that gets filled full of information about this thing. Here we've got the first thing we need to know is, do you have a core? I want this function here, VM set error, and it's part of core. And the next one here is part of core as well, but it could be part of anything else. We set this data up in the structure, do a bit of a hack here. Here, there's a big hack. We're using because we're initializing two things in this loop itself that is unnecessary in C, but it's to make the demo work, or make the print this actually work. I've got to go about it in a way I'm not that comfortable with. These are here. These would be external function pointers. So I'm having to allocate and define them inside this externalized loop. This keeps the pointer to the particular function we're looking for. It'll either be 0 or that location. So we can pass call function that particular location and the parameters, and off it goes. Does its job. Bit of a hack here, as I've just noted up here, big hack here. This will be a pointer to the structure, into the command set. The polling code will write into the target address, the global function address, which is in PBLAN, which would be its index. This is storing not the pointer of the function, it's storing the location of where to write this function pointer, which would be back into this global variable here, in a roundabout sort of way. So the retrieve, the get function does the same thing. It's just we're pulling out the function name we want to search for, and we're calling out a little bit of code here that does a search through our command set. It looks through the particular command set blocks that we requested, finds that block, looks for the function inside that block. If it exists, we return the pointer. If it doesn't, we get nothing. So in theory, you should never get errors out of it. If you do get an error, it's not the end of the world actually, but it would mean that function would cause your application to die. If you ever run a bit of like a command that calls an internal function that is undefined, it will die, if you're lucky. All that convoluted mess. as I said, it's kind of an awkward thing to solve, and here we're doing like a mock-up of what we're doing. I've only bothered to implement this. I've only bothered to implement this for the bank's commands, for this mock-up. The actual functions here I've declared as just print out to the debug window. And here you can see this is how it would call an external function. So normally in PB you would just go b whatever that function is, get error, call get error. But we've used this other method to bypass, because we don't know where this function here is in memory. Now in PB world it does, because it runs through the source code, puts all the source code together up front, it knows where everything is and goes, okay, that function exists somewhere, I know I can resolve where that location is at the end of the compile. That only works if everything's completely known up front. When I compile the new banks library, these functions that we're calling external from here, it has no idea where they are, not a clue. So we need the system to define these pointers correctly for us, so when we hit situations where we're calling these external functions, it just works, nothing goes wrong. As you can see here, we're calling this get error function using call function. If you look at how that function is declared down the bottom here, it's got a print message here. So when we run this thing, I'll go and create bank, check it out again. So this is the information at the bottom. So we'll go through the rest of this stuff here. So this process here is about retrieving functions from a command set. Then we're calling the resolve pass to find, do any of our command sets require pointers from other command sets which would be unknown to them? And if they do, we pass the addresses back, which is what we're doing here. So it looks at the bank command set and goes, okay, I've got two external commands that I need to know where they are, because I don't know where they currently are. And we're doing a search we're searching for core and set error, and we're finding this at, we've got a function pointer or a function index in PB world of 50, and the next one, because the next one's going to be 51, because this happens to be the next function after it. So they're defined, and we look through the command set definitions. We find this is our core, which were defined as part of the runtime file. There's nothing defined under that because we haven't bothered to actually put anything into the demo. And this is our create bank functions and delete bank from the banks library, and down the bottom is the execution of it. So we're creating a bank, and it in turn is calling off to the get error function. That's how it works, man. Alright, I better leave it there. I've been interrupted again. So see you next time. Thanks.